Unit 9 review. Outcome. I can simplify rational expressions. Simplify. M minus 2 over m squared minus 5m plus 6. The first thing you want to do before you simplify completely is to factor the numerator and the denominator. Looks like the numerator is already factored, so we could just bring it down. The denominator, find two numbers that multiply 6 and they add a -5. They're both going to be negative. 3 and 2. -3 plus -2 is -5, and -3 times -2 is a +6. Now from here we can see that the m minus 2's cancel. We're left with nothing in the numerator. You just write 1 there. 1 over m minus 3. This would be your simplified expression. Look back through the example. How confident do you feel about that one? Circle a 1 if you're not sure about this yet, a 2 if it's becoming more familiar, a 3 if you know how to do it but might not know how to explain it yet, and a 4 if you can explain it to your table. Outcome. I can multiply or divide rational expressions and simplify the result. Simplify. First, we want to factor each of these expressions. So we find two numbers that multiply to -6 and they subtract a 5. Let's do a -1 and a +6. Looks like we could factor 6 out of the denominator here. We're left with b minus 8. For where you're dividing fractions, you keep the first fraction, change the operation to multiplication, and flip the second fraction. From here, we could cancel out our like factors. That cancels. It looks like that's it. So your simplified expression is b minus 1 times b plus 6 all over 6. Now, you could either leave it like this, or they sometimes want you to multiply the factors back out into standard form. Outcome. I could add or subtract rational expressions that simplify the result. Alright, so with this one, we have two denominators that are not the same. So to make them the same, we're going to multiply the first fraction by the second fraction's denominator, n plus 1. And we're going to multiply the second fraction by the first fraction's denominator, n minus 5. Alright, so then we have 8n squared plus 8n minus 3n plus 15 all over n minus 5 times n plus 1. Let's combine those like terms. 8 minus 3, 5n. Check to see if we can factor this. And if not, that would just be the answer there. If we could factor it, we would go back to the steps on the first example here. Outcome. I can simplify rational expressions involving complex fractions. Simplify. We have fractions within fractions. First, we want to make the numerator into one fraction. Let's multiply these by 2 to have them have the same denominators. So then we have x minus 2x plus 4 over 4 over 2 minus x minus 2. Now we have a division problem where we're dividing two fractions. So then we can write the first fraction, negative x plus 4 over 4, change the division to multiplication, and flip the second fraction, x minus 2 over 2. From there, we can multiply straight across. Negative x minus 4 times x minus 2 all over 8. And of course, you could multiply these out to have them in standard form as well. Negative x squared plus 6x minus 8 all over 8. So you could have it as either thing depending on what the question would be asking for. Outcome. I could determine the domain or range of a rational function given various representations such as an equation or graph. Find the vertical asymptote, domain, and range of the function f of x equals 3 over x minus 1 minus 2. To find the vertical asymptote, we will set the denominator equal to 0. That's the vertical asymptote. Now for the domain, it would be all real numbers except for x equals 1. An interval notation would look like this. Negative infinity, comma 1, union 1 to infinity. If we were to sketch a graph of this, we'd have a vertical asymptote at x equals 1, and we'd have a horizontal asymptote at y equals negative 2. And the graphs would be going like this. In this case, there are no holes, and there's only one horizontal asymptote, so the range on this one would be all real numbers, except y can't equal negative 2. So that would be from negative infinity to negative 2, union negative 2 to infinity. Outcome, I could use a function's graphical symmetry to determine whether it is an even, odd, or neither. Classify each graph as even, odd, or neither. The first one, we have y equals negative 1 over x squared. This one's going to be even. It's symmetric with the y-axis. And then the other one is going to be y equals negative 1 over x. This one's odd. It's symmetric with the origin. You wouldn't have a function that's symmetric with the x-axis because it would no longer be considered a function. Outcome. I could identify key features such as intercepts, asymptotes, discontinuities, and end behavior given the equation of a rational function. Find each specified characteristic for the function f of x equals x squared plus x minus 2 over 3x squared minus 12x plus 9. The first thing we want to do is write in factored form. Two numbers that multiply to -2 and they subtract to 1 would be a +2 and a -1. And then the denominator we could divide out 3. Two numbers that multiply 3 and they add up to -4. We'd have x minus 1 and x minus 3. So this would be our factored form. From here, the x minus 1's cancel, so we have a whole at x equals 1. To find the y value of this whole, plug in x equals 1 into your simplified fraction. One plus 2 over 3 times 1 minus 3. 3 over -6, that'd be a -1/2. For the vertical asymptote, set the remaining part of the denominator equal to 0. We have x equals 3. The x-intercept, set the numerator equal to 0. X would equal -2 here. And then for the horizontal asymptote, take the leading coefficients of each, the numerator and the denominator, to get 1/3. You want to find these in this order. First, you factor and simplify. Any factors that cancel out would be wholes. Once you get your simplified fraction, that's when you want to find the vertical asymptote, the x-intercepts, and then take the leading coefficient for the numerator and the denominator to find the horizontal asymptote. Outcome. I could identify key features such as intercepts, asymptotes, discontinuities, and end behavior given the graph of a rational function. Find the asymptotes of this graph. It looks like we have a vertical asymptote right here at x equals 0. And then we have a horizontal asymptote on this horizontal line at y equals -2. Outcome. I can answer conceptual questions related to horizontal asymptotes of rational functions. Explain how to find horizontal asymptotes using these expressions. We have x plus 1 over x squared minus 5. They don't have the same degree, so we need to make it so. Now they have the same exponent. We're going to take the leading coefficient of each of these expressions. 0 over 1 equals 0. So your horizontal asymptote is at y equals 0. Now for the next one, they do have the same leading term already. 3 over 1 equals 3. So the horizontal asymptote is at y equals 3. For the last one, we have x squared plus 1 over x minus 5. They're not the same. We need to add 0x squared to the denominator. 1 over 0 is undefined. So there is no horizontal asymptote. Keep circling your level of confidence for each of these examples. Outcome. I can answer conceptual questions related to vertical asymptotes and removable discontinuities, holes, of rational functions. Explain how to find holes and vertical asymptotes using the expression below. X plus 1 over x plus 1 times x plus 3. This would be a hole. And then to get the y part of the hole, we're going to plug in x equals -1 into our simplified expression. 1 over 2. So our hole is at -1 comma 1/2. And then to get the vertical asymptote, set the remaining denominator equal to 0. X equals -3. Outcome. I can write the equation of a rational function given key features such as intercepts, asymptotes, and discontinuities. Write an expression of a rational function containing the following characteristics. X-intercept is -1, 0, the vertical asymptote at x equals 3, and a hole at 2, 15. All right, so first we will write our factors. For the x-intercept, that is to tell us what is going to be the factor in the numerator, x plus 1. In the denominator, we're going to have x minus 3. And then for the hole, we're going to have an x minus 2 in both the numerator and the denominator. But there's more. You want to know what value of a would give you 15 if you had that as a hole. So let's plug that in. 15 equals a times 2 plus 1 over 2 minus 3. 15 equals 3 over -1a. 3 over -1 is the same thing as -3. Divide each side by -3. So a is going to equal -5. So the expression here, the equation would be y equals -5 parentheses x plus 1 times x minus 2 all over x minus 3 times x minus 2. Outcome. I could write the equation of a rational function given its graph. Write an equation for this graph. Y equals -1 over x. So I have 1 over x, and then we have this positive 1 over x, and then we have 1 over x squared, and then -1 over x squared. Outcome. I could sketch the graph of a rational function given its equation. Sketch a graph of the function f of x equals 3 over x plus 2 plus 1. The main thing we want to know is the general shape, which is going to look like that, and the asymptotes. We have a vertical asymptote at x equals -2 and a horizontal asymptote at y equals 1. From here, we'll draw our asymptotes in. Here's our vertical asymptote, and then our horizontal asymptote. From there, we could draw that general shape. If it had a negative where the 3 is, it would just be flipped. These would reflect over this axis right here. Or actually either axis. Outcome. I can sketch the graph of the function and identify key features given a real-world scenario. A company's revenue can be modeled by R of x equals 10,000x over 10x minus 50, where x is the number of units sold. Identify the asymptotes and interpret their meaning and context. So, to find the vertical asymptote, we set the denominator equal to 0. X is going to equal 5. And for the horizontal asymptote, it's going to be 10,000 divided by 10 equals 1,000. The 5 is going to represent the minimum number of units that need to be sold. And then the 1,000 is going to be that revenue. If we were to sketch a graph of this, really interested in this part of the graph, not this one. Outcome. I can solve for values given a real-world scenario of a rational function. It takes Sam 10 hours to oil lanes in a bowling alley. Amy can oil the lanes in 8 hours. Assuming they work at these same rates, how long would it take for them to oil the lanes together? Here's the general formula for this. One over the first person's rate plus 1 over the second person's rate, and you're multiplying that whole thing by t, equals 1 job done. If we plug these into the formula, we have t over 10 plus t over 8 equals 1. So then we have 8t plus 10t over 80 equals 1. Divide that by 18. And then we have 40 over 9, which is about 4.44 hours. Outcome. I can solve for a specific variable given an equation with at least 2 variables. Given ax plus by equals c, solve for y. So we will write the equation, move the ax to the other side, and divide each term by b. y equals negative a over b x plus c over b. Outcome. I can simplify numeric expressions containing rational exponents or radicals. If the square root of 486 equals a square root b, what are the values of a and b? We want to try to take out the perfect square, such as the square root of 4, 9, 25, and 49. These are the most common ones that you can take out. Let's see, can we take out a 4? No. Let's see, how about 9? Yeah, it looks like we take out a 9. The square root of 9, okay, so 9 times something gives you 486. 54. Looks like you could take out another 9. Square root of 9 is 3. And square root of 9 is 3. And then we're left with square root 6. 3 times 3 times square root 6 is going to be 9 square root 6. So A is 9 and B is 6. Outcome. I can multiply or divide expressions and simplify the result using law of exponents or rules of radicals. Simplify square root 5 times 4 square root 5 plus square root 2. We'll distribute that square root 5 into each of those square roots to get 4 times the square root of 5 times 5 plus 5 times 2, square root of those. So then we have 4 times 5 plus the square root of 10. We have 20 plus the square root of 10, and that would be our simplified expression. Outcome. I could add radical expressions that simplify the result. Simplify 3 square root 6 minus 3 square root 54 minus 2 square root 24. Let's simplify these square roots and then rewrite it. So it's 3 times 3 times square root 6, and then this one is going to be the square root of 4 times the square root of 6. 2 square root 6. And then we multiply the other 2. Alright, so if we rewrite this expression, we get 3 square root 6 minus 9 square root 6 minus 4 square root 6. So that's negative 13. We're going to have a minus 10 square root 6. Outcome. I can simplify expressions containing radicals in the denominator. Simplify 8 over 2 square root 3. We're going to rationalize the denominator by multiplying the unity fraction square root 3 over square root 3. We get 8 square root 3 over 2 times square root 3 times square root 3, which cancels out to give you 3. We can divide each of these by 2, and so our simplified rationalized expression is 4 square root 3 over 3. Outcome. I can solve radical equations and determine if a solution is extraneous. Solve. Square root of 20 minus k equals k. Alright, so from here we're going to square each side to get 20 minus k equals k squared. Let's move everything to one side of the equation. 0 equals k squared plus k minus 20. We can factor this. Two numbers that multiply to -20 and they subtract to 1. K minus 4 times K plus 5. We have two possible answers here. K equals 4 or K equals -5. Let's plug them back in to see if any of them are extraneous. 20 minus 4 equals 4. The square root of 16 equals 4. That works. So that means K equals 4 is real. How about K equals -5? Square root of 20 plus 5 equals -5. The square root of 25 is not equal to -5. So that means K equals -5 is extraneous. Outcome. I could graph a radical function given its equation. Sketch a graph of the equation y equals the square root of x plus 4 plus 2. The first thing you want to do is identify the HK point, the starting point here. We have a -4 and a +2. So it's right here. There's no reflections, so it'll be opening like this. Outcome. I can write an equation given the graph of a radical function. Write the equation of function graph below, then identify the domain and range. So it looks like it was reflected across both the x-axis and the y-axis. So we got two negative signs. Our h is 1 and our k is -2. Y equals negative square root of negative parentheses x minus 1 close parentheses minus 2. Sometimes they'll have this negative distributed into the x and that minus 1. Or they might leave it factored out like this. The domain is left, right, x. Looks like the domain of this is anything that's less than or equal to 1. -50, comma, 1 with a closed bracket. And then the range is down up y. It looks like it's anything less than -2. -50 to -2, close bracket. Outcome. I could determine the domain or range of a radical function given various representations, such as an equation or graph. Identify the domain and range of the equation y equals -5 square root x minus 4 minus 1. We did sketch a graph. It looks like it'd be reflected across the x-axis, and we have 4 comma -1. And it'd be opening this way. All right, so for the domain, it looks like it is everything greater than 4. So 4 to infinity. And then for the range, everything that is less than -1. Outcome. I could determine the domain or range of a radical function in a real-world scenario. The temperature of a cup of coffee as it cools can be modeled by the radical function t of x equals -30 square root x plus 165, where x is the time in minutes since the coffee was brewed and t of x is the temperature in Fahrenheit. Determine the domain and range of this function and interpret the meaning of the domain and range in the context of the problem. Assume the room temperature is 70 degrees Fahrenheit. All right, so let's sketch a graph of this first. The x values is the minutes, and then the y values is the temperature in Fahrenheit. So your h is 0, your k is 165. And it's reflected across the x-axis, so it's going to be opening this way. And it's going to stop when the y value is at 70. Let's figure out what the x value would have to be for the y value to be 70. All right, to solve for this, we're going to subtract 70 from each side. And then add 30 square x to each side. Divide each side by 30. And then square each side. And that's about 10. The domain in this case would be from 0 to this number. And it represents the number of minutes for the coffee to cool. And then for the range, it would be from 70 to 165. It's the temperature of the coffee. Outcome. I could solve for a missing quantity in a real-world model of a radical function and interpret its meaning. The time it takes for a rock to hit the ground when dropped from a certain height can be modeled by the radical function t of x equals the square root of 2x over 32, where x is the height of the rock in feet and t of x is the time in seconds. Solve for the height of the rock when it takes 3 seconds to hit the ground, and interpret the meaning of the solution in the context of the problem. Let's set up this equation right here. It says that t of x is the time in seconds, so we're going to replace t of x to be 3. And we're going to solve for the x. Let's start by squaring each side. 9 equals 2x over 32. Multiply each side by 32. You get 288 equals 2x. Divide each side by 2. You get 144 equals x. So this answer basically means that the rock would need to be 144 feet up to take 3 seconds to hit the ground. Of course, this is ignoring air resistance and things such as that. Outcome. I could write the inverse equation of a radical function. Find the inverse of f of x equals the cube root of x plus 1 over 2. Step 1. Let f of x equal y. The second step, swap x and y. And then solve for the new y. Cube each side. Multiply by 2. Subtract 1. And then let y equal f inverse of x. Let's go back through and verbalize what the steps are. So first step, let f of x equal y. Swap x and y. Cube each side. And then multiply by 2. Subtract 1. And then let y equal f inverse of x. All right, go back through all the questions if you haven't already and circle your confidence level for each question. 1, if you're not sure how to do that one yet. 2, if you feel like it's getting familiar. 3, if you know how to do it. And then 4, if you know how to do it and you can explain it to your table group. For those of you that circled 1s and 2s, I would suggest you go back to those sections for those particular questions and look at more similar examples. And if you're still stuck on those, look at other supplemental resources that have been assigned.